Good afternoon, everyone. I think there's a difficult task ahead of me for a couple of reasons. So one are these two great talks that Chenia and Prasenjit gave. The second is I'm heavily jet lagged. So if I look a little sleepy, please excuse me. And the third thing is that I'm standing between you and the coffee. So I'll try to make the best use as I can. So this is a topic, we discuss a lot at our company because we work in the field of education. We are an edtech company. And something here, the purpose of this talk is not to kind of criticize or say, this particular type of model is better than this, or, argue with the numbers that, okay, this model gives better number than that. I mean, some of the numbers and data I've used here are more for illustrative purposes, just to provoke a discussion, right? But not really, to really delve too much into it, because as you know, right, in these days of LLM, new data, new models come out in days, right? You get new benchmarks in days rather than months or years that would have been earlier been the case. Okay. Yeah, just a little bit about who we are. We are Merlyn Mind. We are an edtech company who are in the business of creating workflow automations for classrooms. In fact, we are the first company to have introduced voice assistant for automating workflows for teachers in the classroom.
Teaching isn't a job for me, it's a calling. But what it means to teach keeps changing, just like the world keeps changing. Technology is a huge part of what I do now, and that isn't always easy.
Hey Merlyn, pair my laptop.
Merlyn is the perfect assistant. Being able to control the technology with just the sound of my voice is magical.
Hey Merlyn, open day one presentation.
The less that stands between me and my students, the clearer our connection can be. And that's freedom for me, freedom to teach.
Okay, so you get an idea what we do. And, for our first generation of products, we built something, what we call an edge AI appliance, right? And our natural progression of this from a voice assistant is to look at how we can use natural language in more and more automations in the classroom. So coming back to the topic at hand, right? And the distinction here I'm making when I say generic models are really the state-of-the-art models like GPT-4, ChatGPT, and so on, which have been trained on a generic corpus, right? Of course, you can give it has instruction following capability and so on, but there's some characteristics of these models that I'm calling out here, just to distinguish what I would mean by a domain-specific model, is that they have, there are huge number of parameters, right? And for various reasons, right, these models have been such an architecture of huge number of parameters. They require massive infrastructure, and I've highlighted few of these words because these become very important when you talk about domain-specific models, right? And they're mostly closed. I mean, you know a little bit about it, but they're not really the open architecture models that exist. And they have been trained on a very large corpus of generic data, and all of these access that you have is through an API. So you don't really get to see what this model is actually consuming. But having said that, not everyone needs the kind of control and accuracy that I'll be talking about for a domain-specific model. For example, these models are pretty good, and they have revolutionized some of the workflows, in especially things that are more generic workflows that have more generic characteristics. For example, informational chatbots for support, for going through a corpus and so on. Copywriting, essay writing, sales and marketing workflows, code is a big one, right? And image captioning and so on. So these workflows by very nature are not data sensitive or accuracy in the sense of accuracy critical, because in the sense you have a human in the loop, right? It's not like that if there was even one mistake that it would kind of really cause a big harm, right? Which would typically be the case when in case of when you're talking about finance and healthcare and so on, right? So there is a whole set of workflows these generic models are already enabling and have revolutionized this, some of these industries. But then they also have some of these characteristics which may be very important for some of these industries where where I'm talking about domain specific models, right? Could be very important. For example, and energy consumption is a big thing, right? Because if you see GPT-3, just for its run of training, it has consumed what almost like what like 50 to 60 times of what an average American consumes, right, in a year, right? And these are huge numbers, and I'm talking only about the training part of it. There is the whole inference part of it, which is an ongoing. It's typically, I think, about 1.56 or 1.6 gram carbon equivalent, right, for each inference for this kind of models. So right now, I think we are in a phase where we are, these models are showing the possibility of, the art of possible. But I think it's going to become very important future of how you have, the total cost, right, of these in terms of energy, operation, all of these, right, on an ongoing basis. And for example, in education, which is an extremely price sensitive industry, for us, it's very important to be able to say that, that nobody will pay us money just because of the fact that, oh yeah, you have a great language model. We are very cost conscious industry. So we have to be very careful of the energy and hence the cost footprint of whatever we build. The second is agility, right? And the reason this is important is that these models, if you ask ChatGPT or any of these, right, who is the whatever, a very current information, will say as of like whatever that 2021 when I've been trained, right, and so on, right? The problem is that some industries, for example, in education or healthcare or finance, you cannot afford that because when information change in those industries, the whole cost of anything, right? The cost and implication of anything that happens changes. If I use the information from 6 months, even 6 months ago, right, when a model may have been trained, a typical run of this could be 6 to 8 months, right? That information was used, right? It can lead to huge loss for financial loss or even a healthcare loss for some of the people, right? So here agility, and right now you'd see sometimes some amount of patchy fine tuning and stuff is being done, but I think that's not really where at least we believe this is not where it will finally land up. The accuracy, right? And it's natural, right? Hallucination is natural. It's something that we all in the industry, we all are trying to solve. But when you train a model on such a huge generic corpus, it is very natural for it to make unexpected connections. And for some cases, right? For example, when we are talking about copywriting, essay writing, marketing material, you want creativity. Where does the creativity come from? From the fact that it makes these unseen connections, right? The whole part of serendipity is essential. But for some other industries, for example, education, healthcare, finance, you don't want to make those unnecessary connections because it can have huge consequences, right? If for example, you must have seen this example, right, where ChatGPT was asked a dietary question and it gave a completely hallucinated reference also, right, of medical text from which it said it apparently pulled, right? So these can have very serious consequences in some industries. So we have to be careful about that. And of course, the context, but that's in general, right, for any of these models, right? So and this becomes even more stark when you look at as these three industries, especially I've been talking about, right, education, healthcare, and finance, is that industry regulations are paramount. In education, there's very strict laws governing what you can do with children data, with what kind of data you can collect, where does it go, how are these monitored, the provenance of the data, the provenance of the model, all of that is extremely regulated. And same in healthcare industry, same in finance industry. So in these kind of situations, you cannot expect a generic model having trained on a huge, common crawl, whatever you may say, right? Is something that would be very useful for this purpose, right? Data and privacy, again, a very important question. Where does this data go? What has been, where is and you already see the European Union, already coming down heavily on some of the companies saying that what data has been used, have you followed GDPR regulations and so on, right? So that's another area which is going to be very, very critical for some of these industries, right? Governance, right? In finance, especially, right? A model has to go through audit. It has to go through a lot of different checks before a model is put out, right? With provenance of the data, the provenance of the model, who checked it? Was this a third party, right? All of that. These require a completely new architecture, a completely new mechanism by which some of these can be integrated into the workflow. And the last one is the hope that when you train on domain-specific data, and this is something we are already observing, at least in our case, right, when we have trained on education-specific data, is that it makes much lesser amount of hallucinations as compared to when we used GPT-4, right, or ChatGPT. So, and the other fact is this, right, that do we really need, trillion parameter and hundreds of billion parameter models, right? I mean, that's the first big question. And it has already been shown, in the Chinchilla paper, right, that if you have a fixed flops budget, right, and you are able to train a model, you do not, and you get almost the same performance with less number of parameters, but having trained on much more number of tokens, right? That's really the key. So it's not that having a large model where, the other problem with having a very large model is that you are not cost effective. I may be asking for a very simple answer to a question where you have activated all these different nodes to get me an answer where most of them are not even used. That the multiplication accumulation that you're doing is actually of no use. So we have to start to think about all these aspects, right, of for the purpose I am, and the point Mohajit was also making, right, that for that particular purpose that I have, what is the most useful model, right, that I should use, right? And hence the question that I was asking is that, does one size fit all, right? If I have a trillion parameter model, is that all? Is it done, right? So that's really the thing, right? And you see with this Chinchilla scaling laws, right, that you have to increase the number of tokens that is trained on as much, almost equal to the number of parameters that you increase on, right? And typically it's about 20 times of that. So these are things, right, we should keep in mind when we think about that, the choice that we are trying to make in terms of this huge model versus something which are, and you see many of them, right? I mean, the Alpaca, the stable LM model, the Databricks, Dolly, right? All these models, right? Typically in this 10 to 60 billion parameter model, and they're showing some promise. And of course, the job is not all done, but something that we need to think about. And of course, this comes right from the person who built the best, I mean, at least the company that built the best model out there, right? Is that the age of giant models are perhaps over, and there may be a reason behind him saying that, but we already see some of this, right? Some of why it makes sense, right? As I was saying, right, some of these models, right? I mean, the whole Llama family of models and so on, right? I mean, in this kind of tens of billions of parameters, you already see some very good results, right? And sometimes if they're not good, they may be good enough for us, right? So there's the whole cost equation that we need to worry about. There's the whole liability equation we need to worry about, that if I made a mistake and said that, oh, I didn't know what my model did, I have no clue of what my model did because I have no clue on what data it was trained on, you are going to be in serious trouble, as opposed to having something that is maybe slightly lower in accuracy, but to be able to say that, okay, this is how or where it goes wrong, right? And yeah, so the question here is that maybe the whole thing, right, as you see, the model architecture is more or less kind of getting into some steady state. I think the focus is back on data, right? And hence, companies like Toloka and others, right, it's a great resource, right, for some of these, whether you want to do RLHF, you want to do supervised fine tuning, all of that, right? Perhaps some of that is coming back to data because the model architectures are more of kind of stabilizing now. So the example, this one example is this Bloomberg GPT you guys must have already seen, right? It's the 50 billion parameter model, right? And you see that it's doing, of course, better than any of those other much larger models, right? Because it has been trained for financial tasks, so it does much better than them. But also for generic tasks, right? You see that it's doing reasonably good, right? And that's what I meant when the statement I made earlier, that perhaps it's good enough, right, for some of the generic ones, but for the specialized ones, of course, you have trained it on a particular data set, on that particular domain, right, on that particular instruction tuning for that particular domain, right? It's performing much better, right? And I'm using this example just to show that there seems to be some promise of that, right? People are already seeing some of those benefits, and something that we need to go deeper into. And then, of course, the other one is the chat doctor, right? Which is just a small 7 billion parameter llama model, right? Which has been trained on around 200,000 labeled doctor-patient conversations, and you see it's significantly better than ChatGPT. And again, the good thing here is that at least you know what you have trained it on, right? As opposed to ChatGPT, because where you don't know what you have trained this whole thing on. But again, when you come to medical domain, financial domain, we have to be very, very careful, because the lot more work is needed, because these are domains where it's about human lives or it's about our money, right? Which are both very, very people are sensitive about. So these need more investigation, but I'm using this as two examples at least have in the published paper domain. And in the education industry for us, right, something that we worry about are basically the laws, rules, and regulations. And we have had a great experience understanding this whole industry, because when we introduced voice assistant in the classroom, people asked us, oh, Alexa is there, Google Assistant is there, why are you building a voice assistant for the classroom? And then, what people realize is that you cannot introduce Alexa or Google Assistant in the classroom, because it's collecting data for which you don't know where it is going, right? And there's huge lot of compliance restrictions on how you can use voice in the classroom. And we went through the journey to exactly understand that it's not just so easy, right? That, for example, on the voice assistant days, right, that having said, oh, you can introduce Alexa in the classroom. No, there's no Alexa in the classroom anywhere in the world, at least, and precisely because of the regulations, right? And hence, to use LLM in education, it's not just about picking up GPT-4 or ChatGPT or BARD or anything, right? To just introduce it in this industry, because it will not work, because it's simply because there are a huge number of regulations and oversights that are there in this industry for for you to be able to use any of these, right? And hence, and it's a huge variation of users. It's not like a particular industry that you have like people who have already graduated and then they are working, right? You would find in a doctor's someone with a doctor or an investor and so on. But here we are talking about somebody from grade kindergarten to high school, right? A huge breadth of users, right? Whom we need to cater to. Privacy and transparency and governance is a big concern in this industry, because when we go and talk to the teachers or the decision makers, the first thing is that, what are you doing with the data? Where is it going? If you are saying that you have a model, right? How was that model built? We need to know what was exactly done to build this model, right? So the governance aspect is going to be huge. because we have stakeholders who would not sign off on anything until they are sure that it is not toxic to the students. And but what the view we have is that you have this other extreme where people are saying that, oh, stop ChatGPT use for kids and this one, right? No, we can't do that, because there are huge benefits of this, right? The generative AI is going to bring massive transformation to industries, and we have to look at it in perspective. And for education, we believe that it's not about stopping these tools, but it's about how to use these tools responsibly, how to ensure that we do not harm kids by using these models in a wrong way, or not use training them responsibly. That's perhaps is more important than the fact that oh, don't allow it to use at all. I mean, this is the calculator era, right? When calculator came, people said, oh, calculator, everyone's math skills are going to go down the drain, and nothing of that sort happened, right? So we have to be careful, right, of that of this fact, right? So finally, generic models, right? I mean, they have their own areas and use cases, right? That they do very well on. They are, of course, expensive to train, expensive to the inference cost could be much higher, because you definitely have a larger footprint of those models and so on, right? And what we need to think about is the fact that the smaller models, right, they could be much more useful when you are talking about domain specificity, right? When you're talking about cost implications, right, of industries which are more sensitive to cost, right? In industries where you need open source model, you need open source, proper transparency, provenance, all of that, right? Where just hiding a model behind an API won't do, right? So in all these cases, we should seriously think about how the whole, the open source community that is putting out some of these models, right, in smaller size and much more, capable, right, having trained on a much larger. And you can see, right, these days, 10 billion parameter models are being trained on 1.6 trillion tokens, right? You see that already it is moving towards the fact of what Chinchilla paper had originally predicted, right? That you get better performance, you will get better performance by having a significant larger number of tokens, right? And if you think about training a huge model with that equivalent token, simply that information doesn't exist in this world, right? Think of a 10 trillion parameter model, you would need about 200 to 300 trillion tokens, right? I mean, that amount of information doesn't even exist in text, right? So hence, the choice of whether you can, we should use it, use a generic, these large models which are more closed versus an open, more domain specific models is a choice, something that we should make very consciously. I'm not saying that one is better than the other. For us, at least our view is that these will coexist in, it's almost like, you have a Ferrari and you have a Toyota, right? And they serve totally different purposes and totally different segments of the market. But we have to be very consciously, we should very consciously decide on the fact that which one we should use and take very informed decisions. So in conclusion, we believe that one size doesn't fit all. Thank you.
Guys, questions, please.
So this was good. And one of the things that stood out was you talked about customer support. So are there examples that are working in customer support area? I believe that's more trainable because you have existing data. Language should not be a problem. So I see that as a low-hanging fruit. So just wanted to check. Yeah, no, absolutely. Customer support is something I think is one of the, I would say, the hottest area, right? I mean, it had been, in the chatbot kind of domain, but with LLMs, it's becoming much more prominent. But one thing, right, at least we are looking at when we are looking at our customer support for education, right, is what are called these retrieval augmented models, right? The good thing about these retrieval augmented models is that if I give it a corpus, right, of
of text, it's going to pull it out from there. Tomorrow, if I introduce a new product, I don't have to go and retrain the model. I just put the corpus there, and it can pull up. So you must have heard about many of these patterns, right? Where basically you have a corpus, you have an LLM, you're basically pulling it from the corpus and creating the natural language through the LLM, right? So that is one model which at least I have seen more and more that people, in fact, I think AWS now even has a pattern on their platform, right, of exactly the retrieval augmentation with an LLM.
All right,
Did
thanks.
that answer your question?
Yeah, it did, sir. Thanks.
Wow, so many questions. Nobody want to eat.
So, nice talk. And this question is more pertinent to what you're doing with your organization, like about, automating tasks for teachers. So there are a lot of tasks or a lot of pain points which teachers go through, which are like hidden in plain sight kind of problems, but not solved for. So for example, like I was doing this, study for a client of mine in consumer research. So one of the teachers I spoke to was like, I have to collect student reports from subject teachers. I'm a class teacher. And the subject teacher's English is not good. So I have to solve for, yeah. So, these kind of issues, like I have to solve for problems which are not solved for by the, intellectual models of the world. So are you actually, taking feedback from the cohort, which is actually the beneficiary of your product? And are you then retracing that back to solutions which may or may not be sophisticated in description, but far more pertinent than
Absolutely.
going back to your D to N ratio?
Yeah, that's a very good point, right? I mean, so one is that we believe that we should not do LLM just because it's fashionable, right? And as you said, right, it's much more important that we solve the problem rather than whether I use the an LLM for it, or it could be just simply rule based, right? And what we do is the way we work is that we actually, so we have in our company we are about 120 people, we have about 10 in-house teachers, right, who have taught for like 20-30 years. And then we have some of our the schools and the school districts. So we are mostly focused right now in US and UK, right? So we have our champion teachers whom we constantly spend time with to actually understand, right? Whenever we build something, we go to the teachers and tell them, do you think this is useful? Is this even what are your pain points, right? All of that. So as you said, right, there's a very similar workflow that we know that the teachers, as you said, right, it's not really like day to day, but for example, just report card generation, right? The fact that the teacher has to write a short summary of the child, right, of what progress they made for the last whatever, right, for the last month or whatever, and then put the grades with it and send out an email is a workflow that takes a lot of time for the teacher, right? So what we are trying to see is that how LLMs can possibly automate that, right? Whereas here, the automation and anything, right, in education, there's nothing that happens without the teacher. Teacher is always in the loop because it's absolutely important that anything that is passed through, if there's a report card that's generated, if there's a particular essay that has been graded, all of that, or a question assessment that is generated, all of that has to go through the approval of the teacher. It's just that we augment the teacher to say we make it a verification job for the teacher as opposed to a creation job. That's how we are looking at all these aspects of generative AI.
You said that you have a panel of teachers, right? 10 teachers. So you said that you have a panel of 10 teachers. So this is like a Delphi sort of a group.
Yes.
So
exactly.
How have you selected those teachers? Is it purely on experience, or is it also taking into account some kind of cultural diversity? Because you said US, right? So some Hispanic kind of teachers and so on.
Absolutely, that's again a very good question. So yes, we consider teachers who have worked in school districts that are not the best well-off, right? I mean, so across US there are very well-resourced school districts, there are less well-resourced school districts, and so on. So we have teachers. We have selected that diversity, right? And also the teachers whom we work with we ensure that we have, people, as you said, right? I mean, Hispanic background, right? Teachers who have worked in school districts which were a little more challenging, right? And so on. So we try to ensure that diversity. That's a very good point.
So the last question, to not keep you from refreshing yourself a little bit. So there is Suresh asking, does large language models, I guess, built for the main data by companies have advantage in front of the small models, since these big models can do a lot of tasks? Because from his perspective as a side comment, that one and few short learning are something that large language models can do without even being trained for that. So I guess he has some doubts with domain specificity.
Yeah, no, that's a good question. That's exactly the point I was trying to make, right? That even though we see this large, and I would call large is now relative, right? But let's call it massive, right? This size model, right? Hundreds of billions and trillion parameter models, right? The fact that they are able to do many of these tasks zero shot doesn't necessarily mean, first, right, that they are good for any tasks, right? And the second is that a smaller model may not be good at that task, right? And that's what those two examples that I put there, and there are many more examples where it has been shown that the smaller model trained on a very specific corpus perform much better than a larger model, right? So Suresh, to your point, the point I was making here is that you can do as well or even better with a smaller model as opposed to a larger model, where you obviously can do well, but not necessarily better when you talk about very specific domains. I hope that answers the question.